can you hear me?
Yes, and see you. Hello.
Oh, hello. How are you?
Welcome back from your many adventures.
Yeah, and they're not over yet.
Good. Glad to hear it.
Well, yeah, I'd like to get some work done at this point.
Well, I appreciate your time very,
Yeah.
very much. So
Oh, don't worry about it.
I've been causing lots of disruption and spreading the word and trying to put my back into it. And so I've probably exceeded my competence in several areas, but that's kind of what you have to do to shove things forward. So
Sure.
that's where we're at. So as the expert and as the author of the plan that we're using, I have to say that it's been very well received, and we've gotten lots of interest and solid feedback, and there's plenty of places to move forward. The parts that I know where to work on that we've been working hard on, and then I took your advice to work on propulsion just as hard as the communications to heart. So we've got some good stuff going there. And
Yeah.
actually, it's the engine people that you originally outlined. It turns out that was not on purpose. That but was almost completely by accident that I ran into Shamundra and all the folks that are working on that, and it's come quite far and has flown twice. Um, so this is good stuff that I am
And
growing.
this is the guys that the U.S. Navy Naval Academy were using, right?
I think so. That's BrickSat
Yeah.
or one of the other ones.
Yeah.
Yeah. So this is good stuff. This is propulsion's not my area, but I have learned an awful lot to try to help and to understand how to get it how to get it on board. I think we're going to
Yeah.
have some good results by January, maybe earlier.
Let's back up one step. Since we're talking about propulsion, and that is, how has the whole notion of using a GTO, then modified by varying the perigee altitude, how is that flown with the commission and any other ITU types that you might have talked with?
The commission was very supportive. The experience, even with Mr. Kinziger, was very positive, and the yeah, it got a okay. Yeah, we see what you're doing. Both the modified HEO with the
Mm-hmm.
to not cross over these shells, they got it right away. Like they
Yeah.
understood exactly what we were talking about, and that got a yeah. That's not a problem. There's repercussions for this orbit and all, but like the FCC was they can't pre-approve it or anything like that, but this was very understandable, and it was as positive as you could possibly ask for. The other orbit, meaning straight to graveyard, equally positive, and they said you just need to write the mission plan very carefully because it's unusual. And both of those things, I mean, that's why we then hit the ground, yeah, pretty hard and started working
Do
on the
you
technical plan.
think in that part of the discussion area, when it came to the the sense of amateurs being able to do propulsion technology, do you think the prior phase 3 experiences helped convince them at all?
It didn't hurt. Um, they didn't
Hmm.
ask any. They asked they didn't ask any questions about the history. They also seem to assume that there's a whole lot more of us than there are, um, and kind of assumed that we were. I think probably like as if we were ready to go, um, or
Well,
or that it was
they're used to being told that by the rest of the community, and
yeah.
I think you could also assume they would assume a certain amount of exponential growth because the other parts of the space community are exhibiting that. So
Yeah.
We are a unique factor in that way, and there's nothing much you can do about it because
Yeah.
we aren't experiencing
Right.
exponential growth.
No, we're not. There's a
On
lot
the other
to
hand, I don't think we're experiencing exponential decline either.
not here anyway.
Yeah.
Yeah, we're doing. I think we're doing as well as it. Well, we're doing better than anybody else expected. Um, that you never please yourself, and it always seems like it's going slower than you think it should. But it's
Oh, true.
yeah. But no, the no problem from the commission. So far, no problem from ITU. Um, I think that it's ours to pursue, and
Yeah.
that's how we've been approaching it.
Okay. Regarding the orbit itself, I have been noticing that I I would have expected that by now things would have slowed down with the I guess what I should call what's Elon call this system? I never can remember that.
S-
Starlink?
Starlink,
Yeah,
you're right.
yeah. Well, you would think with Starlink and Friends, which I think is a fair name to call it now. By the way, I've used the Starlink system now, and I'm amazed how well it works. Um, I would have thought the whole pace of new proposals and new applications and stuff would slow down, but I don't think it really has. I don't understand this crazy exponential requirement for more and more orbit shells. I just don't see why these guys think the world is going to embrace all this so as much as they think it will. But anyway, having said that, the market hasn't thinned out very much yet. Everybody's still plunking their money in. And Amazon, I know because I have friends in Amazon that are Qualcomm employees. One were former Qualcomm employees, including Brian Jones, by the way. I don't know if you know Brian. I visited Brian on this trip, and I got a chance to see what Amazon is doing, and oh my gosh, I can tell you. So anyway, bottom line is that I think it could be that the perigee of the orbit ought to be a variable in the trade study right now. And that really means delta V, and that turnaround means mass. And one thing I'd like to do is give you a program that I wrote. It's an Excel spreadsheet, which
Okay.
might help you do the planning because this propulsion stuff isn't all that complicated, really.
No,
And the
it's not too
spreadsheet
bad.
will help you not have to write any more equations than you need to. And we can do the trades. I can help you use it if that helps, and show you how I've been using it. But we can easily, in minutes, calculate the delta V requirements. But I can already tell you probably the number has moved northward from a couple hundred meters per second, or whatever it was I was forecasting, 150 to 200 meters per second. Probably we ought to be planning for more like 300 to 400 meters per second of delta V. And that means hey, can we increase the ISP, which always is easier if you use electric propulsion, but then the thrust and the burn durations become longer because the thrust goes down of the motor. And so there's all these trades to be done that you're now becoming familiar with. Let's put it that way. Yeah. So I could imagine having to have a perigee as high maybe as 1,400 to 1,500 kilometers now, instead of down around it. I was hoping for 1,000 and 1,200, and so I've been moving north as these constellations appear.
Yeah,
I
we
think,
were so far what we've stuck with is 1,250.
yeah,
That's where
as
we're
far
at
as
now.
I know, that still puts the perigee at the highest known shell that I think anybody is using that I'm aware of. And that's something that's worth tracking.
Yeah,
That's really worth knowing what commercials are doing
Yeah, we have been paying attention because there seems to be a trend where the commercial companies will try to keep it come in higher, and they're
and then
told,
move lower.
yeah, which buys them lots of brownie points. And you may as well ask for the highest you can get for lots of different reasons, but then be prepared to move lower. And so far, that's been the trend. But I can
Which
see where it would constantly kind of rise, especially with the sorts of numbers that we're seeing in terms of applications. And
right.
to go back to your question of why in the world would you want to flood like this, it's to try to get rid of every possible competitor as quickly as possible. That's just the business plan of 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 a service industry, really, is to wipe everybody else out by simply flooding the market. So if you can fill up space with Starlink or OneWeb, depending on who gets there first, there's a huge advantage to being there first.
Yeah,
More of an advantage in space than you have for terrestrial products, really.
yeah. In terms of backing horses, I would now put SpaceX way ahead of everybody. But after that, I probably would vote on Amazon second because I know what they're about to launch, and then probably put OneWeb third. And there probably will be a European player, and whoever acquires the license from Thales.
Yeah,
Uh,
yeah, that's a good
there's a
point.
There's another player I know of that wants to do it, but more through the Internet of Things, and they're a big player, and that's EchoStar. And Telesat has had an application on file for a long time, but they've always been talking about a constellation of between 100 and 120 satellites. So that's almost a
Yeah.
non-starter now, I would think, given what Elon's done.
Well,
But
I
there
was
you are. So yeah. So you've got all these shells, and what I imagine is going to happen is the shells are going to try and contract from the high side, particularly. They can't they can't go down any farther, but
right.
they might go up a bit because of the lifetime of the spacecraft being unacceptable given the cost.
Yeah.
So you're going to have this very, very tight band, which means with all those satellites in that small volume, that small, you might call it a super shell.
Yeah.
Um, you don't want to go in there, period,
Yeah.
and you hardly want to go through it once
Yeah.
to get there.
Yeah.
And then they'll be very tightly constrained in altitude. So the eccentricity of the orbits will be darn near perfect, I would imagine, to keep the variability in apogee and perigee down. And it's just going to be this game that's being played, and I think it'll become more and more apparent
Yeah.
and more dense, and those guys therefore are going to have to manage the living heck out of the orbits,
Yeah.
which means that it's got to be a very sophisticated automated system on each
Yes.
company's case to be
Yeah.
able to do that. So that's what I think you're
No,
going to
I
see happening.
I think you're right. It would be what we would do if we had to do this.
Mm.
Maybe not as sophisticated as just volume. Like some some payload has to be at cover this space at this time often enough, and you may be able to just say large numbers are and accept some amount of failure, which
Well, it'll
looking
be
at what has been dropping out, you can see that's um that there's a
it'll actually
significant
be
number.
space, time, frequency, and code.
Space, time, frequency, and code. That's right. Use it
Yeah, that's
all,
it.
and
And
then you
every
maintain your
dimension.
levels, right? You'll be
Yeah.
able to give a really very impressively high uh, level of service. Even with each individual spacecraft not maybe being as advanced or sophisticated or as you might expect. The
Yeah, well, I don't know if you remember good old Lance Jenner, but Lance Jenner's a big Elon Musk supporter. I don't know if he is given what Elon's done with Twitter, but that notwithstanding, he's got two Teslas in his garage, and he's got a Starlink on his roof, and I got to use it, and he was showing me the meter. He was doing a speed test, and he was getting 95 megabits per second. That's faster than I get on NBN here, which is supposed to be fiber. Of course, that's a cheap, but still, I only get about 50 to 70 megabits per second, and he was sustaining 95 forward and about 50 return. So impressive stuff, and pretty small antenna really, and you just plunk it on the roof and it takes care of itself. So I mean, my goodness,
Yeah,
pretty darn cool technology.
we were able to see them up close and in person at DEF CON over the summer in August. So it was neat. The Starlink team was demonstrating with us in RF Village. So we got lots of time to talk with them, and yeah, it's not an enormous antenna. And then
Yeah.
you can look at it and sort of work backwards and figure some things out.
You do have to have a fairly open spot in the sky to look at and all that, but
You do.
that's manageable.
Yeah, for the mountain here, in San Diego, some of the mountains are always tricky to
Sure.
get internet access, and at least one of my friends ordered Starlink. It arrived, and the onboarding process is pretty cool. But the thing looked around and said, "There's too many trees. Sorry," and not possible
Yeah,
to install
if
it.
the sky looks like the picture behind you, you're in a lot
Yes,
of trouble.
you're in trouble.
Yeah.
That's exactly right.
So
So
rainforests don't work very well, and
true.
so
Yeah.
that actually does exclude a lot of people, though, from being able to use these systems. And I still go back to, why would you want to do it via satellite anyway? And the answer seems to be, my gosh, if he's giving you 95 megabits per second, there's a lot of places in the world that can't achieve. I mean, if you're sitting in the middle of San Diego or the middle of Silicon Valley or even the middle of LA, those are unique spots in the world, but not everybody is there.
Yeah.
So I have to review my pessimism for the service in the light of the high speed, low cost, and ubiquity argument. But I still don't think you're going to get 3 billion people on there. I'm sorry.
Yeah.
I'm not buying that.
It's a whole lot harder than that.
Right now,
We know that.
you're getting the early adopters, and you're getting a good percentage of the early adopters, and they're playing with it because it's fun and cool. But that doesn't mean we're getting into the villages in Africa yet. So
Yeah. You're right.
anyway, we digress.
As
But
usual.
but it is worth noting how that is a factor we have to play with, and I mean, there's nothing
Yeah, in
that
several ways.
needs to
There's
be said. Yeah,
yeah, it's
that really is important to keep track of all that, because it's our competition in the orbit space, and to a certain extent the frequency space issues too,
that's true.
because they like some of our spectrum. I bet they'd really love that 47 gigahertz band we have sitting there.
Yes, I've gotten some traction with 47 gigahertz work, and some good stuff. This is all still surplus and somewhat random, and we still have supply chain problems for working on the RF side. We did pick up an additional volunteer that's very
Yeah.
serious about hardware for space and flight hardware, and so that was going to be one of the questions that I bringing to you and people like Thomas Perry. We probably need to start building things that look more like flight hardware, especially for RF chains. The flight hardware for the FPGAs and for the processors can probably wait quite a bit. But I'd like to actually start building things that for the RF side, and to do for the downlink. I'd really like to build 10, and I'd really like to build 24, and I would like to build 47. That's the one that I'm least confident about.
Yeah, I would say
Is
47 looks 24, 47 look like a good transponder for the future, but I don't think we're quite there yet. I think we gotta do this incrementally, just like you said, and everything should be done incrementally.
okay?
Although I guess one thing that's different, I have to adjust my thinking from all this world I'm trying to live in. Uh, Everybody wants how many spacecraft by when, uh, and realize that we probably don't have enough money to do this.
To do
I
which?
mean, it's, well, to play the game that they're playing, which means okay, we launch something every year or something like that.
That'd be
I think
hard.
we should be realistic and say once every 2 to 3 years, we need to kind of do a replacement augmentation, and
Yeah.
do. I think I still like what's called the leapfrog technique. That I have to. I'll give credit is due. I think Martin Sweeting first thought of it in detail, but I gave him the idea, kind of thing. So the idea is you do something that works, and then you try to fly two somethings, and you fly the thing that worked on the next mission, but you then try something novel in
Yeah.
addition. And
Right.
then that becomes the new thing that
Yeah.
works, if you're lucky.
Yeah. If
And
you
and
interleave
and then
and interlock and yeah, it march
so I
through
call
it.
that leapfrogging,
Yeah.
and we should do payload leapfrogging if we can. So you have one old and one new, and
Yeah.
hopefully each time you add a spectral band so that you can at least say you used it, even if it's only a beacon on that
Yes.
band.
No, and we've got a good roadmap, really. I mean,
Yeah. Okay.
the feedback that we got recently, you probably, if you've looked at any of the writing, I try to repeat early and often and get lots of recordings and get all the stuff published. That's just
Well,
what
I
we
need
do.
to find out where that is and start from scratch, because let's assume that I don't know anything more than a little bit. I did not see 100% of that video you sent me the URL for. I
Okay,
saw
yeah,
about
I
half of it, and then I had to go do something I didn't want to do. But
all of
anyway,
it all of it is at the link that I put in the chat, and I'll send it to you in email too. So we're trying to keep everything in one place on the in the repo. So what we've been trying to do is just capture all the work, get it down to as simple to understand as possible without being any simpler, because then you lose important stuff. And some really good feedback from JAMSAT, who will publish. They're going to publish an article coming up here in November in the JAMSAT journal, which is an excellent journal, about this proposal and all the work. And they've welcomed us to meetings, and we'll continue to work with them. What we're proposing is that they be part of this and to throw in and to join up and to help us make it happen. As you know that that's the idea. But
yeah.
since we talked last, there's been presentations and deliveries, and they've responded with publishing the work, which is much better response from JAMSAT than many other organizations. And their feedback back to us about the station capability and about the people in Japan. Basically you're part of the globe. Some feedback about what they want. Another thing that they brought up was to pay much closer attention to the QO100 frequency plans, because we have a 5 gigahertz uplink and a 10 gigahertz downlink, and that's been our MO for a while. And they're like, is there any possible way that we can reuse all of this equipment that we see and being developed for
And
this
remind me,
particular satellite?
what are the two bands they use?
This is 2 gigahertz up, or 2.4 up, 2.4. It's 2
Uh,
gigahertz up and 10 down, so it's different. It's still the same, pretty close to this exact same frequency band that we want to use, but a lower
But they
frequency on the
actually are
uplink.
using 2.4 up, and are they using the bottom 17 megs, which is the primary in the US, or are they using something else?
Let me find a map and make sure that I'm not.
Yeah, the
Let me
reason
find
I'm
out.
asking is since it's in the Wi-Fi band, I could only imagine what Wi-Fi must look
Yeah,
like, even down in channel one right
right.
now. It must be
So
hideous.
I'll put this in the chat as well, and it tells you this is a web page that I go to a lot when I want to introduce people to the idea, and it's 2.4 gigahertz up, and you'll recognize the 10489 down for the for this they have two transponders. One's a narrowband linear, and the other is a wideband digital, which is probably more of interest to us and what we're after. Both are essentially the same band, just slightly different subbands. So you'll see on that page the details of exactly where the narrowband and wideband transponders are located.
Okay.
So
I'm not going to
because
look at these links right now,
no,
but I'm
yeah,
going to
yeah, but
copy them.
right, yeah, the good instincts. Yeah, but since there is a constituency, an audience, participation, lots of activity, it's been wonderful to see. And I've been able to help out a little bit from time to time, even though it's not visible from here. But it's close enough, and because it's a 10 gigahertz downlink. The uplink is different though. You can tell that it's yeah, it's now you're in a different sort of Wi-Fi neighborhood with
Well, I
different
mean,
channel
I think
characteristics and
we have to use a thing we call buying the link. You're going to have to buy the link on the uplink, which means the uplink signals are each amateur signal is going to have to be stronger than the sum of by usually 5 to 10 dB stronger than the sum of the ensemble of uplink noise, calling it noise, you're getting from the aggregate of all the Wi-Fi signals you can see from geo, and that must be humongous. Although I would say that those are going to be weakened by the 1/r squared, the 20 extra dB that you get to geo orbit.
right.
So I
And
guess they figured that out, but I'm really kind of amazed that it's working
it
because of
works.
that.
The transponders are from Mitsubishi. They are modified, the same transponders that are used for the commercial part of the satellite. And so this is a linear transponder.
Yep.
And it's it's a category that is, we should probably point that out just for
Yeah.
they're using
Okay.
linear
And
transponders, and we are a multiplexed regenerative, I guess you call it a regenerative,
yeah, regenerative is a good word.
yes.
Uh,
So we do have a different, it makes it more complex, but we don't have some of the same challenges that they do. It's, different. But we have been asked, like, okay, there's all this equipment and all of this attention and all these articles and all, we've built up a community um, using these frequencies. Would you consider having this frequency plan supported on
how,
your design?
how about another idea? What if you put it as like an adjacent channel? So put it right at the edge of their band in both the uplink and the downlink. The problem is that you get a big buy by using the bottom 2 megahertz of 2400 to 24. I think we are, believe it or not, we are primary in the band 2400 to 2417 in the United States. If we ever used it, if we ever exercised our authority to be primary in that band, I think we'd lose it in about 10 minutes.
Yeah. Alas.
So we have to accept, even though we're primary, which has absolutely zero meaning in that particular allocation, uh, we have to share the interference. So the bottom line is, if you look at the roll off of the filters that are used in Wi-Fi, you'll see that they do roll off pretty good in the bottom 2 megahertz of the band. So there's a big advantage in using the bottom 1 to 2 megahertz as the uplink frequency, because those filters are rolling off all the Wi-Fi noise that would be seen if you look down at the world in that orbit.
Well, when you go look at the webpage, you'll see that the narrowband
Yeah.
linear transponder definitely is in that lower bit.
So
So
the ideal thing would be if we could fit a narrower band version of their thing below that frequency, but I'll bet it goes out of the band.
it's
Uh,
yeah, it starts at 2400.050.
so 50 kilohertz.
Yeah, I don't know. I mean,
Yeah, that's not enough. Or maybe
yeah.
that's 500 kilohertz. But anyway, what I would suggest then is append right on top of that, but you'll lose much of the advantage of the filter, the nominal filter roll off of the Wi-Fi communities. what's in your computer and my
Right.
computer and everybody's computer.
Yeah. Anyway, that was some feedback from all of this work of presenting and talking and meeting and all from the
But
Japanese community.
another thing to think about is you could consider putting a receive channel there, because by and large, receive channels don't cost as much power as a transmit channel, obviously, I guess. Although that may or may not be true for software defined radios, where a lot of the firmware is done in an FPGA, and that burns several watts. What I would say is, if you can get a receiver that can be in the half watt category of power, then it might be worth having two uplinks and then a switch to go between them, or use them
Yeah.
both, or various methods.
Right.
But try and make use of that as the way of trying to feed the family, if you will.
Right.
So you kind of attract people away from QC 100, or Q whatever it is,
QR
um,
100.
QR 100, to be able to uh, show people the new way,
Yeah.
if you will.
Yeah. So it sounds like we could. The core has been 5 and 10, so we'll stick with that. That's what we're doing, and we have a roadmap and advice, and plenty of frequencies really to work with at this point. So 5 and
Yeah.
10 as the baseline, and then we have 24 and 47. We have down to
Well, I hope
2.4.
I can eventually convince you that 10 and 24 are pretty
No,
good.
10 actually 10 and 24 is something we've been starting to talk about a lot, and we of course have our feed. We have a dual
Yeah.
band feed for 10 and 24 now. We're ready to do that. I'm agnostic on the pairing. I like 5 and 10. I like 10 and 24. So to me, since I'm a baseband person and we're spending the vast majority of my time trying to get the encoder and the decoder and the multiplexing working on the FPGA, then you know what? I'm good with either one. So you don't need to
Mhm.
convince me. It's just which can we build and show. To me, it doesn't work until it's working over the air. So I'd really like to start getting an idea of the RF hardware. Not really sure how to do that, except to keep asking wonderful, generous volunteers to help and give
Yes, okay.
advice.
So I have a new input there, and this is a new thread. Unfortunately, I'm going to forget the name, but Gordon and I were at the Small Sat conference,
Hmm.
and we came across this guy who has been, uh, he was a contributor to Phase 3D's hardware payload in Europe. He's a millimeter wave dude, and he builds, what he was selling at the conference were millimeter wave antennas, but he's an AMSAT DL / UK enthusiast. He wants to be able to help us. Gordon grabbed his name and everything. So what I would like to do is, particularly because he's such a good RF hardware delivery, RF hardware designer, radio amateur, full and true blue, and has demonstrated delivery through the Carl Meinzer system, if I can call it that. I would suggest he's a really viable candidate. So unfortunately, I can't remember his name right now, but I've got reference to it. I will send you the email chain that Gordon sent to me, and he definitely would like to participate. I would say, I think he might be Israeli by nationality. He's got a pretty strong personality, and he would have to be managed, but you know how that goes. In, intelligence comes at a cost.
Yeah.
Always, almost always. And I've got the scars to.
Just intelligence comes at a cost, and so does the lack of it.
Yeah, funny how that works. Yeah. So anyway, but I could imagine having maybe a bit of a conference call thing,
Okay.
and I think it would be good if we can convince Gordon to stay in the loop, because Gordon is a wonderful RF designer and
Oh, good.
now has tremendous skills in the millimeter wave department. We're right now working. We just built a payload that was E-band. I think it was 43.3 up and 31 point something down gigahertz for a client, and it's in orbit and working. And we're working on what we call our Gen 4 Ka band system, which goes up to 2.7 gigabits per second. So he's really, and he's been leading the charge on all this. We have team members who are commercial partners and things, and I don't think this would fit into the category of, open sourcing, unfortunately yet.
Yeah.
But that doesn't matter. Gordon's W0RUN, and he's worked on many small amateur satellites as well, including phase 3, C, and D.
Well, bring it,
So,
because
but having said that, he's got not very much time for amateur
Yeah.
radio right now. He's 72 years old, but he's working 80 hours a week kind of stuff. But I can get him attracted to hearing the story, and I know he wants to really try and help out. And his thought was to get this guy plugged in. He said this guy looks like the strongest bet for hardware for millimeter wave for amateur radio.
Well, we need to move forward. So
yeah, okay. I'll try and organize that, and I'll send you the emails that he sent me on this topic.
Okay. Thank you.
Okay.
I feel 10 dB better.
Well, I think also, I don't know if you guys have sort of stopped worrying about ITAR, but I think should. I'm trying to convince you should. Hold on a second. Someone's
Sure.
calling me. They gave up.
Sometimes they do. We're getting inundated with political calls here, so because of
I could only imagine, and let's not get sidetracked on that subject.
But you have all my empathy with phone calls, so.
Yeah.
But yeah, well, you're familiar with our ITAR and EAR work and the success there, so
well, okay. But I'm only, but I actually haven't really read too much about it. But I can only tell you that we don't worry about it.
No, it's
at Astro Digital at all.
Right.
Just say it's EAR 99.
Yep, we did that.
Even if it isn't.
No, we did that. It's all classified. We got the results that we wanted. Lots of hard work and really good advice, and some hard fundraising to pay for lawyers, and it was accomplished, and we've been using it ever since and building upon it and helping other people to build upon it too, because a portfolio is better than a single result in each of these categories. So that's what we've been doing. We are not worried. Good. And well, but I'm not going to say that we're not worried, okay, because you can never not worry about regulatory law, but we solved a problem and we've used the results, and it has been of huge benefit. And so we are open source, and we publish as we go, and we follow the rules, and we are taking full advantage of the good results that we got.
That's what you'd prefer to do anyway.
Yes.
And so there's no penalty for doing that or anything.
No.
I mean, it's the way I think it should be done anyway. The reason I say that is because I think I'd encourage also an increase in international participation, partly because it's worked so well in the past. Mm-hmm. For us, meaning AMSAT in AMSAT's heyday, but because I think some of the best RF designers are in Europe.
Yeah, I think you're right.
I would say
we're already pretty thoroughly international. In fact, there's just speaking solely for myself, it's much more likely that we get a volunteer from a significant, like somebody that's spending a lot of time and contributing technical work. It's much more likely that they'll be from Europe than from the United States. A lot of people that are very active in digital communications, comm theory, and also FPGA design or communications design, if they're from the United States, they express a lot of interest, and they they're encouraged and welcomed to be on the mailing list and to be even come onto the Slack. In most cases, they are overwhelmed and busy, and there's so few of them that these people
it's
are
really
thin on the
hard.
ground. We do have a hardware engineering shortage in the United States. It's
Absolutely.
not getting any better.
No.
Statistically, like looking at all of the surveys and the number of people that go into the field, just looking at hard numbers, you can see that it's been a steady decline for decades, and that decline is mirrored by the increase in software and computer science people. You can see this effect, right? Yeah, we all see it if you've ever had to do any hiring in engineering. Then
I've been following this.
yes. So on top of, like, we're a volunteer organization doing open source work, we're asking you, hey, would you like to donate your time to do for something that is in great demand? You can see that this has been a very challenging thing. So the fact that we've been able to produce high quality work is remarkable, and it's from working very hard and being aware of the shortage, and also being international. Without international participation, without solving the ITAR and EAR problem, we would have shut down in 2018 and 2019. We would have stopped and found something else to do.
On top of that.
We are completely on top of this. What you've said is so completely correct. It's the only way that we're able to do what we do is we have a global participation, as global as possible. Obviously, we have one or two participants from South America that are excellent
probably
engineers.
Don't have too many participations from Moscow, and I would imagine
we don't. We don't have a.
Pretty much out of the question.
We have people that are on the list from China, and we have supporters for, like, on Twitter and social media, and that's it. We don't have anybody from Africa that I know of. We might have somebody that's joined. So when I say that it's global or international, it's Europe and some of Asia. So Japan and yeah, but mainly Europe when we say international, to be totally fair. And
with the exception of South Africa, I don't think we've ever had, and I think I'm speaking in general, the small satellite community, we've never had any participation in terms of RF design or anything like that from any other country in Africa.
We do have some upcoming events that we are aware of that we'll try to support and pay attention to. There's an upswelling of satellite enthusiasm through IEEE, and as an upcoming meetup of young professionals, IEEE YP people in Tunisia. And so it's out there. There's also another sort of a industry or a technical group that tried to get some space stuff started for Africa, and I reached out to the chairwoman of the conference. So we can see that there's efforts and that there's things going on, and at least through IEEE, we're able to kind of keep up with this and keep reaching out. And it's a big ask to ask people to do open source in general, and especially for something where hardware design and hardware engineering, where there's such a shortage. But yeah, without international team, we would simply not have a design. We would not have working stuff. None of this would be able to happen if we were restricted to US persons. It would be much, much smaller. It would not be feasible, I don't think. So,
and in terms of trying to think about the main hubs in the US, the first thing is whatever exists in the Bay Area. And again, even though he's pretty far, poor Lance is now dying of pancreatic cancer.
Oh no, that's bad news.
Yeah, but he's still there and still wants to help. And there's a few people in the Bay Area that can do some good stuff. How about the San Bernardino? Not San Bernardino. The stuff going on in San Diego with Carrie Banke.
Oh yeah, Carrie's Carrie is super helpful, and there's the San Diego Microwave Group in general has been very, very supportive.
Well, his contacts might be among the best that are generally available, and I'm trying to think of others that I would know of that you might not know of, but I don't.
You mentioned San Bernardino, so SBMS.
That's a really, really old group, though. That came out of another part of my brain. It goes way, way back.
Yeah, no, I'm the current secretary for SBMS. We actually, ORI is actually the presentation this coming Thursday at SBMS. So
Wow.
it's
Okay, I didn't even know they still existed. The guys I work with are definitely uh, well and truly gone.
yeah,
Uh,
no, well, the current president is Courtney Duncan, who just retired from
oh,
JPL.
is he?
Yeah,
Courtney Duncan retired.
yeah, he did. And
Whoa. Hey,
well,
if you have his
and then
email address, could you send it? We're really
yeah,
good
yeah,
mates.
yeah, no, I will.
Yeah.
But they immediately hired him back as a contractor.
Oh. So is he working out at Goldstone or something?
No, I think he's working at JPL trying to help him keep the helicopter alive. So
Oh, cool,
yeah,
cool.
yeah, because all the people from the helicopter are kind of trying to retire, and they were like, hey, wait a minute, we can't have all of you people
You
leave.
guys
We've
retired. We got to keep feeding the helicopter. So
That's
they
right.
haven't crashed it yet. That's something I also didn't know. I figured it by now that it crashed it.
There's a conflicting set of stories about how beat up this poor helicopter is, but it's still, and they want to do
Whoa.
another one, so they can't let everybody wander off.
Oh,
So
that was so cool.
yeah. Yeah, no, and he's a buddy of ours and super supportive and wonderful, and so
Oh, Court, you couldn't
that's
do
why
better than
I make
Courtney.
the drive up to Corona, California every month to
Mm.
serve the club and to learn stuff from the community. It covers
I want
everything
to try
from
and get plugged back in with him if he's retired now. That would be really cool.
okay, yeah,
Uh,
I'll make it happen.
Tell him I'm looking forward to talking to him. Oh gosh.
Yeah, it's good stuff and a good group and lots of they still have a pretty active surplus scene, so we've been able to get components.
Yeah.
Your all of your silver boxes, this came from SVMS, these bag of stuff came from SVMS, I mean, and if I got a 47 gigahertz covered dish,
Oh, cool.
rig thing. It looks amazing. I'm so happy.
How much
And
gain?
a lot,
A
scary
lot.
amount of gain.
I know, probably a little thing like that has got about 45
Well,
dB of gain.
it's like it filled the back of the truck, right? So it's a pretty honking
Oh, that
thing.
big.
It's
No,
pretty,
that's
yeah, it's not dainty.
that's
All right. So it's
uh,
like, I'm scared. So, don't stand in front of it.
well,
So
tell me how
anyway,
big the aperture is, and I'll tell you what the gain is.
okay. I'll take a look at it because I haven't even taken off the little cover. It's got like a radome and everything. So, I mean, this group is
Neat.
great. It's a fantastic group and they've been super supportive and
Well, I think it's
positive and
important.
helpful. I
One
mean,
thing you can do is try and thread those groups together and get them aligned and get a purpose going and get a project. All they need is a big mutual project with a fantastic goal. I'd say that's the way to make that work. It's always worked for AMSAT to do that,
yeah.
and there usually is a response if there's a goal and if there's a date associated with it. You can
Yes.
get just do a demo launch of something.
Yeah. Yep. You're
Okay.
right. You're
Okay.
exactly right.
And now if we switch gears a little bit, because I'm probably gonna have to go,
Okay.
uh, is anything that can help you with in the what I call project management advice,
Yeah,
quality
absolutely.
assurance,
I
putting
do.
together stuff to build a what you call a R&D prototyping capability, which has got to be good enough quality that it can fly. In other words, everything amateur radio flies is a proto flight at best, and it's never going to be flight hardware by the Lockheed Martin definition of what that means or any of that. Of
Yeah.
course, we know that, but what I mean is, I think I can help you put together the kind of labs and stuff that would be needed to get that going and
Yeah.
help you project manage it as
Yeah.
best
The
I
any
can
help on
from
this would
afar.
if any and all help on this would be appreciated. I've got some amount of expertise here, but I need this to work as well as
Yeah.
possible. So
And
I need expert advice.
the other thing I'll volunteer to do is if you want an official keeper of a link budget, I think I'm sage enough to be
Yeah,
able
I
to do
think
that.
you might be. Yeah, you're hired.
Okay. So
Sorry,
so
you're
yeah,
hired.
I'll need to ask a lot of questions because a lot of this will be in firmware now. In other words,
Yeah. No, and surprisingly, there's all sorts of opportunities and really cool things that we can do. Oh, there's all sorts of strange ways and different implementations and choices and trade-offs, and it's just one big gigantic roiling mass of a trade study. And
yeah.
but you know what? The wonderful thing about this group and about the organization and about the way it's evolved is that we're completely unafraid to just go do it and try it and commit to it and do our best and keep hitting it with the tire iron until it gives up and works. And
Well,
that's been
when we
like the best
started, we
part.
didn't know it. When we started, we didn't know it couldn't be done.
Right.
And
Sometimes it's good to not know.
when I walked in the Delta project office and put Oscar 5 on the table in front of him and said, "I want to launch this,"
Yeah.
I saw some incredible looks. But
Yes.
guess what? It got launched.
That's right. No, I'm with you. And so okay, so we should is there is there any way that you can accommodate like regular meetings? Do you do that sort of thing? I know that this is a
I think
controversial subject for regular
no,
meetings,
no,
but
no, but I can try to. I'll give you a downer headline on that, and that is I'm headed for Hawaii in on the 11th for about the better part of a month. That's
cool.
actually good news because from that hotel system where I know I'll be staying, I've got good internet coverage. And,
Yeah, that's good.
and I haven't promised the XYL that I would stay completely disconnected during that time since we've had so much time away this year. So
Okay.
I think even then I could probably do half-hour type
Yeah.
uh, connects, maybe even up to an hour, and maybe on a regular schedule. And then I'll be only 3 hours off your time,
That's true. Well,
which
I
is
mean,
better than it's
is it
better than
3
six
hours? Is it
from
3 from
Hawaii. I think
Hawaii to
Hawaii to
San Diego? It's like 3?
I think it's
Yeah,
three
3 or
from
4.
he.
Okay. Yeah,
Yeah.
that's what I'm happy to get up whenever. But
Well, don't worry
but
about that.
but
Maybe I'm
but
one
but
because
closer is good. So not
closer is
complaining.
better.
Yes.
Three is
Yes.
better than six
It is. And
by three.
it's better than Japan.
Ooh.
It
Well,
is.
Japan is the same as us, by the way.
It is. And I love their meetings. So they have a monthly meeting that's fantastic. It's remarkably awesome. They have multiple hours of presentations that really it's like every month is a conference. That's great. But
Oh,
it's
I see.
really
That's cool.
really early in the morning. Oh wow, is it early? So it's
But
been
they won't speak all English
ah,
during
I
that,
have
I'm
I have
sure.
I have a solution for that. So I have this called a time kettle, and these are little earphones, and I play the audio from. So they do some. There are some English presentations. Like when I present, I give it in English, and then whatever needs to be translated is translated by very generous members of JAMSAT that are very good at translating.
Mhm.
But the Japanese part, so the time kettle will translate it to my phone and I can at least follow along. Now, this does reveal some very amusing things. For instance, filter is translated as hygiene. And so you just have to know that the mechanical translation is going to choose some interesting words. And once you kind of learn the
Once
pattern,
you can hear them, yeah.
yes, you can kind of get it. So I follow along with that if a presentation is in Japanese, and fortunately, technical presentations for amateur satellites, not too bad. The slides themselves often tell almost all the story, and then
Yeah,
in
good.
between, so it's just been
It's
it.
this
And
plot
I'm
diagram or whatever.
proud
Yeah.
to be a member of JAMSAT. Have been to their symposium in the past and hope to be
Mhm,
able to go back in the future when
mhm.
we're able to travel. And that's been a good thing. So it's been educational and wonderful. And so I'm happy to do it. Just a little early, just
I know.
a little painful, but that's okay. It's completely worth it. And you know what? A lot of JAMSAT people get up for meetings that we have at ORI, and I know that it's like extremely early for them. So if we split the burden back and forth, then it works out. So I don't know, when do you want to meet next for like a half hour to touch base
Mhm.
and to do this? Can you meet before you leave on the 11th?
Yeah, maybe we try and make it the 10th,
Okay.
see how it goes,
About the
and
same
put that
time?
in nominally. Yeah.
Okay.
Let's try that and see how it works.
Okay.
Yeah. It and what I may even set a goal. I don't know if I can achieve it, but to try and see if I can get Gordon to join in,
Yeah, that'd be awesome.
and he can then present a little bit more about his thinking about this guy and what he's talked to him about. Apparently had a couple of conversations about the whole idea of trying to fulfill this guy's goal of trying to he has his own ideas about crafting, I think, a payload for an advanced amateur satellite. He's
Awesome.
been thinking
Well,
about it for a while,
great.
so
I
let's see how that goes.
can't
And
wait.
yeah, I'll see if we can make that happen. If it doesn't happen then maybe I can do it, the following week or whatever it takes.
Yeah.
uh yeah, oh boy, we're going to full blast on a proposal right now that's really got Gordon's mind fully occupied. But I'll tell you, we're doing some amazing things. We're doing all digital transponders. I mean, right down to everything but the RF amplifier. I mean, it's pretty
Awesome.
amazing.
That's fantastic.
Is It's mind-boggling the rates you can sample at these days. Let's put it
Yeah.
that way.
No, it's
Wow,
scary stuff.
scary
It's
stuff.
I love it. I'm so completely thrilled. I think that has to be a blast.
Yeah. It it's also mind-boggling, and I have to tell you, the most scary thing about any of this, quite frankly, Michelle, that we never had to deal with in the past was the time rate of change of technology. In other words, the derivative of technology increase has gotten so steep, so positive that I don't, it's not possible really to keep up with it. Not, I would imagine it's hard for some young people to keep up with the time rate of change of these technologies. We cannot buy a device which will be useful in a program that takes a year to create
Yeah.
a product, a spacecraft,
Yeah. No,
because that by the time that year has gone by, people have lost interest in that device because it's obsolete.
this has led to this is true, and it's not just for space hardware, but this seems to be happening all over anything that touches
Everything.
computing, and that's led to burnout. People get
Ex-
overwhelmed and they start to feel like they're no good at engineering because they can't keep up, and it's no one can keep up, period. But if
It
you
keeps getting faster and faster. It's
yes,
exponential growth, and
it,
we humans don't deal well with exponential growth in the
no,
limit.
no,
In
we
the
don't.
limit, we just
No, we
don't.
really don't. And if you're not forgiving of yourself, or if you miss that part and you feel
Yeah,
obligated, if you feel like you have a moral obligation to keep up, then you're going to burn out, and burnout is bad. It means
yeah.
lots of time to recover once you
I've lost two or three colleagues through burnout. I mean, totally lost them. It might as
yes,
well have died. They
yes,
might as well have died because they
it
were of no value anymore in terms
it
of
can be that
the
severe. It
project.
could lead to bad depression. It's a loss of, like, you're not able to function. It's extremely,
Yeah.
so this rate of change, not having a good impedance match as a human to the rate of change, and not recognizing that, you know what,
I
you
think
can't.
that's a huge problem for technologists, for
Yes,
engineering generally, and I think it's underestimated how important that problem is.
I could not agree more. I don't think it's talked
Okay.
about. I don't think we know how to deal with it yet. And just for the grace of God, do you do, do you figure
Well,
it out? And
I'll be honest, and that is I can't deal with it, and I can't figure out how to deal with it. So the best way is not to allow myself to think of the absolute latest things that are happening
yeah,
because I can't.
yeah, it makes your head
Simply
explode,
can't.
you know.
Yeah.
And once your head
Yeah.
explodes, it's hard to put all that stuff back in there. Burnout's bad. So anything, I don't know. Yeah, you're exactly
But
right. You
even the fact that we know about it, or we could agree that it's a major problem, doesn't solve that
no,
problem. And I don't know how to solve this one. I've tried my best to think rationally about how to approach it, And I haven't come up with any decent solutions. None.
Yeah, me neither. I think we've been struggling with this since the Industrial Revolution or earlier. And
Well, but then the derivative was like this. Now it's
yes,
like that.
yeah, yes, exactly. It's critical. So
Yeah.
see, another thing to worry about.
Well, yeah.
All
But
right.
it's even on this project, it's kind of preventing me from being able to say what I could advise you to do or what I should do myself. Because even in the discussions we've had, I think the change on the whole transponder concept has evolved at a pace where I can't tell what's real and should be thought of as something we can actually do between software development and hardware development,
Yeah,
and
that
the
line.
synthesis of those, and what is not real because it's a good idea, but it isn't really quite there yet.
Yeah.
And will
Fortunately,
it mature enough in the time frame that we need it to be able to actually build it and design it and deliver it?
yeah.
Hey,
Fortunately,
last
you're dealing with some people that are somewhat grumpy and do have good low pass filtering. So we we're
yeah,
simple is
that's what you
better.
need, a good low pass filter.
You do.
That's
That's
exactly it.
that's the only secret that I have to share is that a really solid, good low pass filter
Okay, good
will
low
help you.
pass filter is
So I think we're good. We've got a good handle on some of the stuff. Oh, ADAC, no idea. You had stuff picked out in this proposal that looked like it was off the shelf, and we've done nothing more on that yet. So attitude control, I'm hoping that it's available and that we just look at the next generation of
I do
whatever's
think it's an
available.
area, it is an area where open source might be a good approach. And the other is the old AMSAT idea of trying to get a donated copy of something like a Star Tracker or some wheels
Yeah,
because people want to fly them.
yeah,
That, in other words, it would provide credibility. But then we get to that issue, which is a good segue into it. Basically, that's my ADAC idea, and I've got some people I can help. I might be able to help in that area, at
oh good.
least kickstart things.
Yep,
Uh,
yeah,
but that gets to the last subject, which is in order to provide everybody with the confidence that this is going to happen, how we do it on the launch options.
I don't have any idea on even how to define launch options because
So you haven't
so,
talked to any launch providers. So one,
no, I don't have. No, I haven't, and maybe I should have been all along. But I haven't, mainly because I'm like, we do R&D. So like that's why spending time trying to get collaboration with AMSAT North America not really didn't really work. They want us to just go away and think we're a threat. And so no, that didn't work. They've not been coming up with launches themselves, so they don't have any to really share with us, and they don't want to. That's one of the reasons why I went to JAMSAT and said, collaborate, help us out, path forward, move
JAXA
forward.
might just be willing to do that. JAXA and the vehicles they have are big enough. Now, the big problem with those are they go to pretty specific orbits, and but they do, I think, they do can and do geos.
Yeah,
So
and they
that
they
that's
they had there's a multiple examples of their they had emergency communications plan for HEOs that that I've seen in the literature. So I mean there's stuff there to at least build on, or and
yeah,
also
Pentagon.
ESA. So Libra Space Foundation, we have very friendly relationship with them. We're a signatory to the Libra Space Manifesto, open source all the way, and ESA may include us in some of their stuff. We have 2 sounding
Okay,
rocket
that's good.
launches coming up. So we're on sounding rockets, and we are building at
Yeah,
least some relationships with, because you have to fill out all this NASA paperwork, and it's the FAA and the FCC. We're making progress filling out all this stuff and understanding how to do it. These experiences have been very positive. No, they're not orbits. They're suborbital sounding rockets. But, so that's what I've been doing. So if there's something that I need to also do in addition to this, I just figured, like, if we design something that's really amazing, that we will be able to get a launch, and that building the relationships with people that are the ones the organizations that are supposed to be helping us with launches, like the AMSAT organizations and organizations like LibreSpace, that building a collaboration with them is the way forward. If we're supposed to be getting a launch all on our own, we need a lot more people. We really do. And we need people that are very familiar with this process. You
Yeah.
know, that, so I get, so that's kind of the thumbnail sketch of what I've been up to.
Rather than talk about it now, let me write some thoughts down, because but I have lots of potential leads and ways to go.
Okay.
They range from trying to see if we could embrace Rocket Labs, because Doug Sinclair is on their board and a major contributor. I don't know if you know Doug, but he's a Canadian guy that I've worked with for years, and AMSAT really helped the Canadian spacecraft most, and Doug was on the most team. I know both Doug and Kieran Carroll, who think the world of the small satellite process, and would probably be willing to help us. From that to the guys who took over, I can't remember the name right now. They're going to be launching soon though, and they have access to the launch pad Slip 2 West, which is where we always launch from. Almost all the earlier AMSATs and Oscars were launched from that pad. So it's the Delta launch vehicle has retired, and now it's been replaced by a commercial. And those commercial guys know of us and would take us seriously.
Okay.
So I've got
Good.
a contact there. Again, JAXA is a good thing. And of course, through Carl and others, we have old ESA contracts, which might work into the system that exists now within AMSAT. What's the name of the NASA free launch initiative thing that
Ilana.
Ilana. So that's always still available in principle, although you're competing with all the universities in the world.
Yeah, that's true.
But in terms of comm payloads, we can participate. We can compete. We can say, well, we want to try some comm technology ideas, and nobody else can actually do that.
Yeah.
So if you think of that as a niche, that's probably viable.
Yes. Yeah, I agree. It's worked.
Play that card.
Okay. No, I'll look around. The one of the sounding rockets that we're involved with is through the University of Puerto Rico. So that's exactly what we're doing, is providing communications. Really neat, so we're taking our uplink protocol, which is new and has some innovative stuff in
I
it.
want to learn about that uplink protocol. Probably is the #1 thing on the comm site.
Yeah, it's coming
That's
along.
on.
It's
I
cool.
can find the definition for that and that URL you sent.
Yeah, if not, I'll make sure that you get it. There's a the right. I'll make sure you get the right link for the uplink protocol. But that's what they're using, so it's that's what's on board.
That I need to understand the modulation process, like forward error correction coding used to that.
Yeah, you got it.
Link, an appropriate link.
We'll have an article.
You may already have a link budget on that. You may already have a link budget on that, but I'd like to be able to replicate.
Yeah, no, I think we definitely need link budgets for the applications that we're doing. As a for the protocol itself, there isn't one right now. At least I don't think there is. No, there's not. So yeah, we could use some help there, especially because since we're moving forward with the University of Puerto Rico and they have a particular frequency, a particular application, and we're starting to look at particular implementations. The very next thing is a solid link budget for them. So they're already asking for it.
Okay, so that would be good. So let me try and dig into that.
Yeah.
So that's kind of one specific analytical thing I could probably do. Let's see. The other thing, what was it I wanted to mention? Oh, yeah, I know what it is. Some new ideas. Well, the old way we would test a payload would be to fly it on a balloon. But it
Hmm.
seems to me we've got extra balloon options. The guys who used to fly balloons a lot were the guys that were in the Denver area. I don't know if they still do it.
There's some in
The
Denver,
area
and there's a
coordinator with AMSAT was the guy who used to run that group. Jack, can't remember his name.
I can see if that's still the same person. There are opportunities in there, and there's also active group in Texas, and there's some groups out here too. So I think that's a good
Yeah.
idea. We have
But
options.
balloons, but you now have the new entry into the world is drones.
Hmm.
And while flights, the altitudes will be lower
Yeah,
and the flights will be shorter and the ranges will be correspondingly shorter, it still may be a really good way to test out things from a early standpoint. In other words, really early prototypes that may not be able to withstand the environment you get at 100,000 feet
yeah,
might at 10,000 feet actually survive, and you can get early tests done. So my idea was to try and get a big drone and put a payload on that. And at millimeter wave, the antennas won't be big, so that's kind of cool.
that's true. We do have a volunteer that's very active in open source drone. And
Yeah,
he is volunteering with the team in Estonia that reversed the DJI, um, some of the DJI protocols
yeah.
and stuff.
And then there are
So
the big
the big
balloons that are
constraint with
small.
the drones that we found out, because
Yeah,
the first question was, can our downlink protocol, because we do open source DVB-S too, and they want to do high def video on drones. The first question was, can it work? And the latency for the feedback loop from the person with the goggles trying to use high def video, to drive the drone, some concerns of the latency. So what this particular you know blob of people have done is something pretty interesting. They've taken LTE, more of an LTE signal, so
yeah,
OFDM, and really leveraged thrown everything else out except for the low latency and enough bandwidth. And that protocol is going to get published very soon, and they intend for it to be open source. Now, I mentioned LTE. If there's anything in there that is LTE, then you have a IP problem. And
yep.
so that's what we're going to go try to do, is as soon as we can, to review it and to see if there is any problem. Um,
Hmm.
and if not, then that's another protocol that we can add to
Well,
the things
one
that
of the
we.
big problems with off-dam that I'm generally aware of is it creates a lot of spectral fine structure, let's say. In other words, narrow little chunks that are kind of added together.
Yeah,
And that kind of signal structure is usually tends to be quite sensitive to Doppler.
yeah.
So the real question is, can you solve the Doppler problems, especially in millimeter wave where the Doppler is megahertz instead of kilohertz?
Yeah, they say yes, because as you know, drones can change direction very quickly and can accelerate very quickly. And so they started out with that as a concern. Now, did they pull it off?
Yeah, but
We'll
I'm talking
we'll
about
see.
if you use it as a methodology for a drone or
Yeah,
balloon, does
yeah.
it translate then into a space technology?
That's a good question. So yeah,
Because
we'll
you're not,
we'll
now
see.
you're adding about 18,000 kilometers
Yes, you
an
are.
hour to the speed. So
Yes, yes, exactly. No, so there's plenty of cool technical stuff going on, and I'm really,
yeah,
really hoping that the drone part of what we do
oh,
will
you're already on it.
very soon get published, and we'll be able to actually see and maybe help with some implementations. And
Yeah.
they're asking for help with RF hardware, of course. Everyone is, like we talked about earlier. And so yeah, there's plenty of this neat stuff going on, and a lot of it's going to work. Some of it won't, and
Some
and
of it won't, some
documenting
will.
and documenting the stuff that does not work is very important, because
Absolutely. Agree.
most people don't ever come back and admit that it didn't work and explain why. And we have made a conscious decision to go ahead and document failures and to tell what doesn't work so that nobody else will go down this same cul-de-sac.
Well, they probably will, despite your best efforts, but
Yes.
that's another issue. People ignoring what's been published in the past and
Yes.
pretend that this is all brand new, and then they launch out on it
Yeah.
anyway and
Yes.
and then
You're
stick
right.
their finger in the fan again.
Yes.
Okay, well, okay, then in that group of drone and balloon, another thought is there are some super balloons that are more than in the offing now. In fact, the community that wants to fly commercial high altitude transponder systems for commercial internet service and stuff like that
Yeah.
must be by now reaching some level of maturity. It's a market I've not paid any attention to, but those guys probably are launching stuff for which they wouldn't mind having a piggyback on it.
Oh, okay. Yeah,
So
this is, are you talking about
that's
like
the number.
projects like Loon, Loon,
Well,
like the
you,
Loon people,
you
or?
I'm actually looking at it from a spectrum management perspective, first of all, and that is there's now spectrum that it's been allocated to a service that seems to have a name, an acronym like HEPA or HEPA or some name similar to that. Check it
Okay.
out.
All right.
But those guys have spectrum now, millimeter wave spectrum that's been allocated for the purpose, I think, of mostly internet, but maybe
Yeah.
IoT and maybe other high-speed digital services,
Yeah.
commercial services, and they've been, of course, held back a lot by the whole technology of a high-altitude, stable platform that isn't that easy to engineer,
Right.
and that they've been trying to do that. I mean, the proposals have been around. I remember Andy Viterbi saying, "Oh, that proposal comes around every 10 years or so.
Yes. Yeah.
I bet pretty soon it'll be real." And so that's Andy Viterbi telling me
Yeah.
that 20 years ago.
Yeah.
And so they keep trying. So I
Yeah.
think this is another technology area where there's going to be an opportunity to fly alternative payloads. Now, that may not be a free option, but it
Right.
might be a longer term option. In other words, you might be able to use the transponder for a month or two
Yeah.
over
Instead of
a couple of
9,
states,
right.
you
Instead of
know,
90 seconds on a sounding rocket
and it might work
versus,
over 300 or 400 kilometers.
yeah.
So that's actually
Yeah.
a useful, serviceable idea. So
Yeah.
that's one to try
Okay.
to look into.
Yeah. Very good. All
Okay,
right. Thank you.
I think that exhausts my
Yeah.
thoughts for today.
Yeah. My head's full. I've got plenty. I've written everything down. So
Well, thank you, dear.
I'll make
Uh,
a memo, and we'll go
okay,
from here, and I'll set aside time on November 10th. If you can meet up again, then I think that we'll
okay.
be able to move things forward. So thank you. This
So
is
my action items are
all of
to
this, all sorts of
one,
look.
send you yeah. Will you then you
Yeah,
send me my action items and I'll
that's
respond. How's
dangerous
that?
now.
Well, I'll do what I can.
I hear you. Me too. I'll do all that I can. This
All
is a blast. It's the best job I've had in a long, long time, and I
right.
really, really appreciate your time. It's wonderful. So
Okay, very good, and let's push for success here.
you got it. All right.
All
See
right,
you soon.
take care.